find the domain and range of this function, this quadratic function. So first of all, let's have a quick think about what this might look like. It's a quadratic function. And we know it's a negative quadratic function, so it's concave down, with a y-intercept of -3. So perhaps it looks something like this. We don't know exactly, but let's go with something like that to start with. Now, given that, it looks something like that. First of all, the domain. Well, for any quadratic function, we can input any real number value into x. We can calculate it with any real value of x. So the domain is going to be the set of all x values such that x is a real number. Now the range is going to be slightly different because the range is we need to find the maximum, and it's going to be all y values below that. So we need to find the maximum. So there's two ways we can do that. I'm going to show you both. We could do the line of symmetry. So the line of symmetry is x equals minus b over 2a. That's going to be minus 4 over minus 4, which is equal to 1. So that means the x-coordinate here is going to be 1, and we need to find the y-coordinate. To find the y-coordinate, we substitute into the original function. Get minus 2 plus 4 minus 3 gives me minus 1. So the vertex is going to be at 1, minus 1. Alternatively, we could have completed the square to find it in vertex form. So to do that, we would start off by factoring out that minus 2. Minus 2, x squared minus 2x minus 3. Now we do the square part, which is going to be x minus 1 squared minus 1. We take away the extra bit we get from if we were to expand this. And then that's going to become minus 2 times minus 1 becomes plus 2 minus 3. So minus 2x minus 1 squared minus 1, which tells us that vertex is at 1, minus 1. Either way, we get the same coordinate. You can choose which one of these approaches you prefer. Once we've got that coordinate of that vertex, we now need to find the range. Now the range is going to be all possible values below that vertex. So the range is all values of y such that y is less than or equal to -1, because it's everything below that. It also tells us that our graph here was not quite right. The x-coordinate's about right, but the y-coordinate's not. Maybe I want to update this, and the easiest way to do that is actually to move the axis, and now that looks about right. And we can see that this function has no roots when we do that, because the vertex is below and it's a concave down one. We found the domain, and we found the range. And remember, you can choose which of these two methods you prefer. It really doesn't matter as long as you can find the vertex of that quadratic to do this.